Good morning, class 7. This is the part 2 video of lesson number 13, motion and time. In the part 1 video, we learned about what do you understand by time, how do we measure it, what are the various devices we use to measure time. And also we learned about the time period of the simple pendulum, how to calculate it. That was part 1 video. Moving on to the part 2, I told you that in this video we will be discussing about motion and speed. Okay, let us understand what is motion and what is rest, right? So rest and motion in physics, how do we define them? Okay, look at the left side of your screen, the left side picture. You can see a tree, you can see a house, you can see an electric pole. Do they move? They don't move, isn't it? So they are said to be at rest or stationary. Look at the picture on your right. What do you see? You see a man kicking a football, you see an insect buzzing, and you see a bird flying. So all these four objects are moving. They are in motion. They change their position. So they are said to be in motion. So an object can be not moving, then it is said to be at rest. If it is moving, then we say that it is in motion. So let us again see the difference between rest and motion. A body is said to be at rest if its position does not change with respect to a fixed point in its surrounding. How? Take the example of this book lying on the table. With respect to the table, the book is not moving. Similarly, the bench in a park, with respect to that lake, the bench is again not moving. So, both the book and the bench are said to be at rest. What is motion then? A body is said to be in motion if its position continuously changes with respect to its surroundings. For example, if the bird is flying away from a tree, it was there sitting on the tree, then it is at rest. Suppose it begins to fly away from the tree. So, its position keeps changing with respect to the tree. Then we say that, yes, the bird is in motion. This boy here, this little boy with a ball, imagine he is running towards the goalpost. So, with respect to the goalpost, the distance keeps becoming reduced. So, the boy as well as the ball are both in motion. But remember that motion is a relative term. What do you understand by relative? It means that with respect to certain object, we may feel it is moving. But with respect to other object, it is at rest. Let us understand this in the next slide. Okay, we'll do the definition of motion later. Concentrate on the picture on your right hand side. Okay, what do you see there? You see a person A, you see a person B and person C, right? Person A is on the ground. He is not moving. He is stationary. Person B and person C are both in the hot air balloon. Okay. Now suppose I am person C. I am there, right there in the hot air balloon. So, with respect to person A, okay, if you see person A, then I am moving. Okay, I am in the hot air balloon, I am moving. But A, since he is stationary, with respect to A, I am moving. But with respect to person B, okay, with respect to person B, I am not moving. We are both in the hot air balloon and we are not moving. So the same person, when I compare with A, yes, moving. But when we compare with B, not moving. This is what is relative. Okay, so in relation to A, I am moving. In relation to B, I am not moving. So let us define what is motion. Motion is an object. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. Let us recall the types of motion that you have already studied in your earlier classes. What's the first type starting from the left? You see the vibratory motion. That is all the string instruments, the sitar, the guitar, all of them show this type of vibratory motion. The oscillatory motion or the swinging motion that is shown by the pendulum. Then you have the circular motion, an object moving in a fixed circular path like the revolution of the earth around the sun. Then you have the rotatory motion, that is the blades of the fan moving along the axis, that is called as rotatory motion. Then you have the curvilinear motion, a boy aiming to shoot a penalty. Okay, he makes the ball curve and goes into the goal post. That's a curvilinear motion. So a motion in a curved path. And the last and the most important is the linear motion. This is the example which we have seen time and again. And any body moving in a straight line is called as a linear motion. Now look at this picture. What's happening here? It's a picture of a running race. You have a few boys running on a track. So, are you interested to know who's fast, who's slow? How will we know who's running fast here, who's running slow? So, you have a finish line and the boy who comes to the finish line first is the winner. Why? Because he's the fastest. So, who's near the finish line here? The boy right near the first, that boy in the navy blue t-shirt, navy blue and light blue t-shirt, he seems to be winning the race. Isn't it? So, does he take less time than the boy in the yellow t-shirt or more time? What do you think? Yes, the boy in the blue t-shirt takes less time. Who's faster? The boy in the yellow t-shirt or the boy in the blue t-shirt? Of course, the boy in the blue t-shirt. So, the boy who takes less time is faster and the boy who takes more time is slower. Right? Let us take the example of this beautiful blue color car. How can you find how fast or how slow this car is moving? You find this device, the picture of which you see on your right hand side. It is called an odometer, a device which is present on the dashboard of your car. Every car will have this near the steering wheel, just behind the steering wheel. You'll find this. Can you see the dials with markings of 0, 22 to 80? So that tells you the speed. What is the speed of the car now? Where is that needle pointing, the red needle pointing? It is pointing at 140 kilometers. So it means that this car is moving with a speed of 140 kilometers. You also find certain numbers below this dial. Can you see? Slots there, white slots in which numbers are there. What does that tell you? It tells you the kilometers or the distance covered by the car. When it first started, it would have been 0. Okay, when you would have bought this car from the showroom, the readings would have been 0. And slowly, as you keep using the car, the kilometers keep adding up. So this is a wonderful way of calculating distances. The speedometer is present in every two-wheeler, four-wheeler, except cycles, it is present in all the vehicles. So using this, you can easily calculate the distance from your house to your school, from your house to your market. All the distances can be calculated based on this. Isn't it a wonderful device? So, coming to the definition of speed. So, speed, we already said that it tells us how fast an object is moving, right? So, speed is the distance traveled by an object in a unit time. Unit is what? 1. Okay, 1. So what is speed? By definition, speed is the distance traveled by an object in a unit time. So the unit time could be 1 second, 1 minute or 1 hour. So speed tells us in 1 minute or 1 second or 1 hour how much distance an object has traveled. Right. Let us see this picture. See the picture on your left. You see a car. Okay. You see a car which is traveling from city A to city B. Right. At what time does it start? It starts at 9 a.m. And what time it reaches city B? It reaches at 11 a.m. So 9, 10 and 11. So it takes a total of 2 hours to travel this distance. How does it travel? Let's see how it travels. So first 30 kilometers, it travels at a speed of 30 kilometers per hour. Okay. It travels the first 30 kilometers of the journey at a speed of 30 kilometers per hour. Then 0 kilometers it has travelled for the next 1/4 hour. It means for 15 minutes the car did not move. It stopped. That's why 0 kilometers. Then again it started. And this time it covered 15 kilometers. And what was the speed? The speed was 20 kilometers per hour. So how to calculate the speed in this case? It is very difficult. This is how most of the vehicles will move. They will move at different speeds. Isn't it? Through traffic you have to move, through highways you have to move. So we will have different speeds. So that is why we consider a value called as an average speed. Okay, in most of the books we will find only the word speed, but it implies the average speed. So what is the formula for average speed? Average speed is equals to total distance divided by total time. Okay, let us calculate in the case of this car. We already saw that it takes 2 hours. So the total time will be 2 hours. Okay, what is the total distance now? Okay, let us calculate. It first it travels 30 kilometers, then it travels 0 kilometers, then again it travels 15 kilometers. So add all these three. What is the distance? 30 plus 0 plus, isn't it? 30 plus 0 plus 15, that is 45 kilometers. So what is the average speed? It would be 45 kilometers divided by what is the time taken? 2. So this is kilometers and this is hours. So what is the average speed? It is 45 divided by 2. That comes to around 27.5 kilometers per hour. So that is the average speed or speed of this car. Right? Let us move on to the units of speed. Isn't it? Whenever you measure a quantity, you need to have the units. Right? So what is the formula? Formula is speed is equals to distance by time, or S is equals to D by T. So what is the unit of, what is the distance? The distance can be measured in meters. The time is measured in seconds. So one of the units is speed is meters per second. Okay, this is for short distances. If you want to find out, you can express the units as meters per second. But if you're traveling large distances, say from one city to another, this will be too small a quantity. That time you use this unit, kilometers per hour. You can change meters per second to kilometers per hour or kilometers per hour to meters per second. It can be done. How it is done? See the second picture on your right. Okay, so here 1 kilometer is equals to 1000 meters. We all know this, isn't it? Similarly, 1 hour is equals to 3600 seconds. How did we get this? 1 hour is equals to 60 minutes and 60 minutes is equals to 60 seconds, isn't it? So 60 into 60, how much is that? 60 into 60. 60 into 60 is 3600 seconds. So 1 kilometer per hour is equals to 1000 by 360, right? 360 00 is equals to 5 by 18 meters per second. So 1 kilometer is equals to 5 by 18 meters per second. So you have to calculate kilometers per hour to meters per second. You simply multiply the amount by 5 into 18. 5 divided by 18. If you have to do the reverse, you have to change meters per second to kilometers per hour. Then you multiply that quantity by 18 divided by 5 and you will get your answer. Here is a small, you can say a figure which will help you to understand the formulas for speed, distance and time. So here we have got three quantities here, isn't it? We have got three quantities. We have got distance, we have got speed and we have got time. So the first formula, you can arrange this in the form of a triangle. Okay. So write D here, S here and T here below. Okay. Now suppose I want to find out distance. So distance I have to find out. What about the next two quantities? Speed and time are written side by side. Okay. So you multiply them. So distance is equals to speed multiplied by time. Right? This is formula number 1 to calculate distance. Okay. Now, same picture. Now I want to find out time. Okay. So time you don't write. How is this thing? D, there is a line divided by S. So you write D by S or distance by speed. So time is equals to distance divided by speed. This is the formula for time. Now I want to calculate speed. Same thing, S is colored. So I write here speed is equals to what? D is above, then there is a line divided by T. So this becomes D by T. This is your third formula. Right? So using this picture, I can easily calculate the any of the three quantities asked. If distance is asked, I can calculate. If speed is asked, I can calculate. Or if time is asked also, I can calculate. I have to apply the correct formula. Here is an example. Okay, I have worked out a small numerical for you. Let us see how it is done. Let's first read the question. A wheelchair racer completes a 100-meter course in 20 seconds. What is his speed? Okay. So we are interested in finding out the speed here. The speed is the unknown quantity. What is given? D is given and T is given. Okay. D is given and T is given to you. So what do you know? Distance. What is the distance? 100 meters. Okay, is the distance. What is the time? 20 seconds is the time. What you don't know? Speed is the thing that you don't know. What is the formula for the speed? You can just draw that diagram that we did, isn't it? We did D here and S and T here. So, here we are interested in finding speed. So, S is equals to D by T. Same thing is written here. So, first step, this is the first step. You write the formula. You write the correct formula. Okay. Second step is substitution. What the quantities have been given to you. Instead of D, you write 100 meters. Instead of T, you write 20 seconds. This step is called as the substitution formula. While doing substitution, you have to remember a small thing, that if the distance is in meters, the time should be in seconds only. It cannot be in hour or it cannot be in minutes. Then it will be wrong. So if it is given in minutes, you have to first convert it into seconds. Then only we can calculate this. Okay. So that alone you have to take care. Now second step we have done. Instead of writing D, we have written 10 meters, and instead of 100 meters, and instead of writing T, we have written as 20 seconds. Now the third step is you have to calculate and simplify. So 100 divided by 20 is 5. Right? And the fourth step is writing the answer, which is 5 meters per second. So this is how you do the numerical. Okay. I'll give you more examples regarding this. Then moving on to the speed. So earlier we calculated, isn't it, that speed can be uniform or it can be non-uniform. How so? You look at the picture which is above. Okay, so this is a car or any vehicle which is traveling. So at 10 kilometers, at 20 kilometers, at 30 kilometers and 40 kilometers, they have given the time taken. So they have taken in 5 minutes, it travels a distance from 10 kilometers to 20. So what is the distance traveled? 10 kilometers, isn't it? The second instance, again, the next 5 minutes, it travels from 20 kilometers to 30 kilometers. Again, the distance is 10 kilometers. Next 5 minutes, it travels again from 30 kilometers to 40 kilometers. Again, the distance traveled is 10 meters. So every 5 minutes, this car travels 10 kilometers. So this is what is called as a uniform motion. So equal intervals of time, equal distances covered. Now take a look at the picture below. The examples of such a uniform motion would be the hands of a clock, isn't it? It moves at uniform, or the movement of the earth around the sun. So both these are examples of uniform speed. Okay, sorry, uniform speed. Right. So look at the picture below. Okay, what is the time interval here? 10 minutes and 10 minutes. But what is the distance traveled from 10 kilometers? It is traveling to 35 kilometers in the first 10 minutes. The distance covered is 25 kilometers. But in the next 10 minutes, it is only traveling from 35 kilometers to 40 kilometers, which is only a distance of 5 kilometers. So in the first 10 minutes, it travels 25 kilometers. The next 10 minutes, it travels only 5 kilometers. So this is an example of a non-uniform motion. For example, a vehicle moving through a traffic or a child playing, all these are examples of non-uniform motion. Now, how do we plot this in the form of a graph? Okay, I believe we have done bar graphs, but you're not familiar with line graphs. Okay, I'll try to explain it to you. Even if you don't understand, it's not a big deal. We can understand it slowly. You can play the video again and again, or if you still don't understand, you just give me a call. I'll try to explain it to you. So see the left side column, you find a tabular form of the time and the distance. Okay, you have the time in minutes and distance covered in kilometers. So first 2 minutes, in 2 minutes it travels 2 kilometers, 4 minutes it travels 4 kilometers, like that the whole thing goes. Okay, now we have to plot this in a graph. So what do? You plot the time in the x-axis. Okay, time along the x-axis and the distance covered in the y-axis. So we start with 0. And what is the time? 2, 4, 6, 8, 10. So you plot here 2, 4, 6, 8, 10, 12, 14, 16 and 18 kilometers. 18 minutes. And on the y-axis you plot the distance. You say 0, 2, 4, 6, 8. This is in kilometers. So it's 0, 0. Okay, the line here. At 2 2 minutes, what is the distance covered? It is 2 kilometers. So I put the point here. At 4 kilometers, it travels 4 kilometers. At 6, 6. At 8, 8 kilometers. At 10 minutes, 10 kilometers. At 12, 12. At 14 minutes, 14 kilometers. At 16 minutes, 16 kilometers. And at 18 minutes, 18 kilometers. Then what do? I join this by a straight line. And what do I get? I get a line, isn't it? How is this line? This is a straight line. Why? Because this body was moving at a uniform speed. It was covering uniform distances in uniform intervals of time. That is why I get a straight line. Now suppose this tabular form is not given to me. Only this graph is given to me. By looking at the graph, I can find out whether it is a uniform motion or a non-uniform motion. Okay, by looking at the graph. Suppose, can you predict at 25 minutes what is the distance travelled? Can you tell? Yeah, it is going to be 25 kilometers. Isn't it? Because every minute it is travelling 1 kilometer. So this is the usefulness of this graph. So plotting the distance time graph for a non-uniform motion. In a non-uniform motion, how can you plot this? Look at the table on your left hand side. What do you see? You see the time and you see the distance. 2 minutes, 2 minutes. But what happens at 8 minutes? It has travelled only 7 kilometers. And at 10 minutes, it has travelled only 8 kilometers. So we put the dots. Okay. At 2 minutes, 2, 4 minutes, 4, but at 6 minutes, 6, at 8 minutes, 7, and at 10 minutes, 8, and at 12, 9, 14 also, 9, 16 also, 9, and 18 also, 9. What does this 999 mean? It means the vehicle has stopped. So if you see a straight line, it means the vehicle has stopped. So slowly it is increasing, but here it stops. It's not moving further. As the time moves, this is not moving. So you don't see a straight line. So when you don't see a straight line, it means it is a non-uniform motion. Now let us see the three vehicles, okay, each represented by a different color graph. You see the green line here, it represents the uniform motion, a straight line, uniform, steadily increasing motion. You see the blue line, it is steadily increasing, then it is stopped, and then again it is decreasing, the speed is decreasing, finally it is coming back to the same position that it started. See the red line. So from 0 to 2, when all the other things were speeding, this was at 0. It was at rest. It did not move at all. Then it started to move, started increasing, and finally came to a stop. So this is how you interpret the graphs. So that is all for today. So this concludes our lesson. Hope you understood. If you haven't understood any part of it, feel free to message me or call me. Thank you.